SpaceX has put an extraordinary number in its own investor documents. The company says one Starship launch could eventually deploy up to 60 next-generation Starlink V3 satellites, with each satellite designed to provide 1 terabit per second of downlink capacity. SpaceX calls that a potential 20 times increase in Starlink capacity deployed per launch compared with Falcon 9. And this is no longer only a distant presentation slide. In its latest quarterly report, SpaceX says Starship Flight 13 deployed 20 production V3 satellites in July, while also completing an in-space Raptor relight and the softest Starship splashdown yet. But the headline needs discipline. 20 times capacity per launch does not mean every customer suddenly receives internet that is 20 times faster. It does not mean revenue multiplies by 20, and it does not prove Starship can already carry 60 satellites on a repeatable schedule. It means the bottleneck between building network capacity and placing it in orbit may be about to change. Today, we will separate the demonstrated milestone from the company target, calculate what 60 V3 satellites could add, and identify what SpaceX still has to prove before this becomes a durable advantage for investors. The 20 times figure measures downlink capacity deployed by one launch, not household speed and not total network performance. As of March 31st, SpaceX reported approximately 9,600 Starlink broadband and mobile satellites supporting more than 700 terabits per second of cumulative downlink capacity. The new broadband V3 design is intended to provide 1 terabit per second per satellite. A full load of 60 would therefore represent up to 60 terabits per second of designed downlink capacity placed into low Earth orbit by one Starship mission. SpaceX says that is 20 times the downlink capacity deployed by a Falcon 9 Starlink mission. There is an important category distinction. These V3 broadband satellites are not the same product as SpaceX's dedicated direct-to-phone constellation. The company describes separate broadband and mobile satellite families with different capabilities and deployment plans. So this episode is about the main Starlink internet network, not a claim that ordinary phones receive 20 times better service. Even for broadband, design capacity is not immediately usable capacity. Satellites must reach their operational orbits, deploy hardware, establish laser and ground links, pass checkout, receive spectrum authorization, and be positioned where demand exists. The launch is the beginning of the capacity pipeline, not the end. Starlink V3 and Starship were designed as parts of the same expansion loop. Falcon 9 made the present constellation possible, but its payload volume and mass limit how much new network capacity SpaceX can deploy in one mission. SpaceX's prospectus says Starship V3 is designed to carry 100 metric tons to orbit in a fully reusable configuration, while a future Starship V4 could potentially reach 200 metric tons. That larger transport system allows SpaceX to pursue satellites with greater data density instead of optimizing every design decision around the smaller Falcon fairing and payload envelope. The company has not publicly disclosed every production V3 specification, so claims about exact satellite mass, power, antenna count, or manufacturing cost should be treated carefully. What is disclosed is the intended output: 1 terabit per second of downlink capacity per V3 satellite and up to 60 satellites on a Starship launch. That is vertical integration in its purest form. SpaceX designs the launch vehicle, manufactures the satellites, operates the network, sells the terminals, and collects recurring service revenue. If the rocket improves, the satellite business can scale faster. If network demand grows, SpaceX creates an internal customer for Starship. The two systems reinforce each other, but they also share risk. A delay in Starship becomes a delay in the capacity expansion plan. Flight 13 moved this story from a paper target to an early operational proof point. SpaceX's quarterly release says the July mission achieved all flight objectives, deployed 20 production V3 satellites, demonstrated an in-space relight of a Raptor engine, and completed Starship's softest splashdown while returning views of an intact heat shield. Each result matters for a different reason. The satellite deployment tests the payload bay, release sequence, flight software, and initial orbital delivery. The engine relight supports controlled orbital operations and future mission flexibility. The intact heat shield and soft splashdown provide data for recovering and eventually reusing the upper stage. But Flight 13 carried 20 V3 satellites, not the 60 described as the eventual per-launch capability. 20 is 1/3 of that stated full load target. The mission also ended in the ocean, rather than with an upper stage catch and rapid reuse. Investors should recognize the accomplishment without promoting it into a capability that has not been demonstrated. The next proof is not simply another beautiful launch. SpaceX needs to show that production V3 satellites activate successfully, that the vehicle can increase its payload load, and that Starship can repeat missions without long refurbishment or investigation cycles. Flight 13 opened the door. It did not finish the system. The reason this matters financially is visible in SpaceX's second quarter numbers. Starlink reached 12 million subscribers, twice the year earlier level, while quarterly connectivity revenue rose 66% to approximately $4.3 billion. The segment produced about $1.7 billion of operating income and $2.6 billion of adjusted EBITDA. Consumer revenue was approximately $2.5 billion, while enterprise and government connectivity revenue reached roughly $1.8 billion. Capacity supports all of those businesses. More usable bandwidth can allow SpaceX to add customers in crowded regions, improve consistency during peak hours, sell higher value service to aircraft and ships, and support government and enterprise contracts. But subscriber growth also reveals the pressure. Starlink's reported monthly subscriber revenue per user was $66 in the second quarter, down from $85 1 year earlier as the network expanded internationally and added lower price plans. That makes efficient capacity growth even more important. SpaceX must support more customers and more data without allowing satellite, launch, ground network, and support costs to rise just as quickly. A 20 times improvement in capacity deployed per mission could help that equation. It still cannot guarantee demand, pricing power, or profit by itself. SpaceX argues that a fully and rapidly reusable Starship could eventually reduce the cost of reaching orbit by 99% or more relative to a historical NASA average of $18,500 per kilogram. That is a company projection, not a cost level Starship has already demonstrated. The current development program remains expensive. SpaceX reported roughly $1.1 billion of space segment research and development expense in the second quarter, with the increase driven partly by Starship production, engineering, launch, and testing. The company is spending now because the potential operating leverage is enormous. A mission carrying 61 terabit satellites would spread one launch campaign across far more network capacity than a Falcon 9 deployment. Fewer launches per terabit could reduce vehicle processing, range coordination, labor, and schedule pressure, while a reusable upper stage could avoid rebuilding the most expensive part of the transport system after every flight. But the sequence matters. Starship must first deliver the payload, survive re-entry, return close to its recovery point, be recovered, be inspected, and fly again quickly. If the upper stage remains expendable or refurbishment remains lengthy, part of the promised cost advantage stays theoretical. The economics improve only when high payload and high reuse arrive together. Even a perfect 60 satellite launch would leave 5 bottlenecks. First is satellite production. SpaceX has to manufacture V3 units fast enough with high yield and consistent performance, or Starship will wait for payloads. Second is orbital activation. Design capacity creates value only after satellites deploy, reach their operational positions, connect to the network, and remain reliable. Third is launch cadence. A large payload helps, but a 20 times advantage becomes transformative only when missions repeat frequently. Fourth is the terrestrial system. Gateways, fiber backhaul, laser links, customer terminals, spectrum rights, and local regulatory approvals must expand with space capacity. A congested ground network can waste capacity already in orbit. Fifth is demand quality. SpaceX can add millions of lower-priced customers, but investors also need to watch revenue per user, customer acquisition cost, enterprise contracts, and service margins. There is also a concentration risk. Starship is becoming the planned deployment vehicle for V3 broadband satellites, future mobile constellations, lunar missions, and potentially orbital compute. That makes one rocket extraordinarily valuable and extraordinarily important. The bull case says vertical integration compounds every successful launch. The bear case says a Starship delay can propagate across several SpaceX growth engines at once. My verdict is that the 20 times figure is one of the most important disclosed targets in the SpaceX investment case, because it connects rocket engineering directly to recurring connectivity revenue. Flight 13 provided meaningful evidence by deploying 20 production V3 satellites. The 60 satellite launch, rapid upper stage reuse, and 20 times operational cadence are still targets. Watch 5 signals from here. 1. Confirmation that the Flight 13 V3 satellites reached their intended operating state and began adding network capacity. 2. A Starship mission carrying materially more than 20 V3 satellites, eventually approaching 60. 3. A recovered upper stage followed by a measured refurbishment interval and a genuine reflight. 4. Starlink service metrics showing that new capacity improves peak performance or unlocks customer growth without destroying revenue per user. 5. Connectivity margins continuing to expand after satellite depreciation, launch costs, support, and ground infrastructure are included. If those signals arrive together, Starship stops being only a spectacular rocket and becomes the manufacturing and logistics backbone of SpaceX's most profitable operating segment. If they do not, 20 times remains an impressive design objective rather than an investor result. Subscribe for the source documents, the operating metrics, and the distinction between what SpaceX has demonstrated and what it still has to prove. This is SpaceXInvestor.